You're listening to Major Gazer. I'm your host, Callie Cross. Tonight we're looking at fast radio bursts from deep space, their precise 16-day cycle, and what the pattern might actually mean. There is a telescope in British Columbia with no moving parts. It does not point. It does not swivel. It just sits there, a fixed array of cylinders and wire, scanning the entire overhead sky every single day as the Earth rotates beneath it. The Canadian Hydrogen Intensity Mapping Experiment, CHIME, was built to study dark energy. That was the plan. Then, within months of switching on, it started catching something nobody designed it to catch. Radio pulses, milliseconds long, arriving from billions of light years away, each one carrying more energy than our sun releases in days, compressed into a flash shorter than the blink reflex in your eye. Fast radio bursts. And CHIME found them by the hundreds. That is where this starts, not with speculation about what these things are, but with the documented reality of what they do. Because the documented reality is strange enough on its own terms that you do not need to reach for anything beyond it. The first fast radio burst was not caught in real time. Duncan Lorimer at West Virginia University found it in archival data from the Parkes Observatory in Australia, a signal that had arrived years earlier and sat unidentified in storage. That paper came out in 2007. The signal itself had traveled to us from somewhere on the order of 1 billion light-years distant, arrived, and no one noticed for years. The field of FRB astronomy opened with a discovery pulled out of a filing cabinet. Since then, CHIME's published catalogs have logged over 500 FRB detections. Most are one-time events. A pulse arrives, and that source is never heard from again in any observed window. But a smaller subset repeat, and one of them does something that generated a genuine, active scientific debate that has not been resolved. FRB 2018-0916b repeats on a 16-day cycle. Roughly 4 days of burst activity, then 12 days of silence, then 4 days of activity again. The CHIME FRB collaboration published this in Nature. It is a peer-reviewed, multi-instrument finding. The periodicity is not in question. What is in question is what produces it. And that gap between the cycle is real and we know what makes it is exactly where things get interesting. 3 competing models are on the table right now. 1. The source is in a binary system, and the 16-day period reflects the orbital motion of a companion object that periodically blocks or distorts the emission. 2. The neutron star producing the bursts has a precessing jet, and the geometry of that precession sweeps the beam in and out of our line of sight on a 16-day rotation. 3. Some other geometric or environmental effect tied to a binary companion, without direct blocking, changes the conditions for burst emission on that schedule. None of these has been confirmed. None has been ruled out. The CHIME FRB team's Nature paper establishes the cycle without endorsing any mechanism. What would it take to distinguish between those models? That is a question the field is actively working. The answer involves more observations, longer baselines, and almost certainly more telescopes. Now, the first known repeating FRB, designated FRB 20121102A, behaves differently. Shami Chatterjee at Cornell was part of the team that used the Very Large Array to localize it to a specific host galaxy, a dwarf galaxy roughly 3 billion light-years away, sitting near a persistent radio source in a star-forming region. That localization was a landmark. It gave researchers an actual environment to study. FRB 20121102A emits in clusters, sometimes dozens of bursts in a short window, then goes quiet for extended stretches. There is a reported activity cycle for it as well, around 157 days, though that one is described in the literature as messier, less cleanly periodic. Treat it as a claimed finding rather than a settled one. Here is a detail about these bursts that does not get enough attention. Some repeating FRBs show fine structure on sub-second timescales, microbursts packed inside a single event. Based on light travel time arguments in the literature, this constrains the emission region to something smaller than a city. The object producing a flash detectable across 3 billion light-years fits inside the footprint of a mid-size urban center. That is not speculation. That is geometry applied to timing data. The strongest physical clue we have about what these things actually are came from inside our own galaxy. A magnetar, designated SGR 1935+2154, produced a burst that CHIME and the STARE-2 array both detected. Magnetars are neutron stars with extraordinarily intense magnetic fields, and this one produced a radio burst that, if it had been located in another galaxy rather than our own, would have looked like an FRB to us. Multiple independent instruments confirmed it. Papers came out in Nature and the Astrophysical Journal Letters. The magnetar FRB connection is now the leading physical model with direct observational support, which means the framing you still see in a lot of popular coverage. That we have absolutely no idea what produces FRBs, and therefore the door is wide open for any explanation, is doing a lot of work to avoid acknowledging a peer-reviewed finding. The energy argument is worth addressing directly because it comes up constantly. The claim is that FRBs release so much energy in so little time that no natural mechanism could be responsible. But magnetars, which are known natural objects with well-documented physics, are capable of producing the observed energy outputs. The SGR 1935+2154 detection is the evidence for that. Extreme energy does not imply non-natural origin. It implies an extreme natural object, which is exactly what a magnetar is. The SETI Institute has noted FRBs as worth monitoring. That is a reasonable, scientifically defensible position. No peer-reviewed work has argued for artificial origin. The popular version of this story, which moves quickly from the 16-day cycle is unexplained to could be a beacon, skips over the actual scientific conversation, which is a competition between 3 natural models, none of which involves anything but astrophysics. There is a moment in Liu Cixin's 3-body problem where a repeating signal from a known direction becomes the pivot on which everything turns. The signal is periodic, structured, and that structure is what makes it unmistakably different from noise. I think about that a lot when I read about FRB 20180916b, because the honest version of the question is, what would an artificial signal actually look like that would be distinguishable from what we observe? That question has not been formally operationalized in a way that makes the hypothesis testable with current instruments, which is not a reason to dismiss it. It is a reason to notice that we have not yet built the framework to answer it. What we have instead are genuine open questions that deserve that label. Are repeating and non-repeating FRBs physically distinct objects, or are the non-repeaters simply sources we have not watched long enough? Can the magnetar model account for the most energetic events in distant galaxies, or does something else need to be invoked? Why do some repeating FRBs show a downward frequency drift over time, described in the literature as a sad trombone pattern? What role does the host galaxy environment play? These are not rhetorical gaps filled by speculation. They are specific, documented unknowns that active research programs are trying to close. And CHIME is at the center of that, a telescope that was supposed to study dark energy, built with no moving parts, and ended up cataloging the most complete FRB dataset in existence because the sky kept rotating overhead and the instrument kept listening. The signal from what became the Lorimer burst arrived in 2001 and sat in a file for years before anyone recognized what it was. There are almost certainly more signals like that in archives right now, waiting for someone to look at them with the right question in mind. That is not a dramatic statement. It is just what the history of this field actually looks like. That's Major Gazer. Thanks for spending some time under the sky with me. See you out there.
Grab news. Thomas.